In this video, I'm going to show you how to sketch quadratics in vertex form using just the vertex and your intercepts. So first up, we're going to need to figure out how to get the vertex from a function in this form. This form, by the way, is called vertex form. Vertex form is when you've got some plus or minus stuff in your brackets with your x that you're squaring, and then some plus or minus stuff on the end, roughly speaking. So broad strokes, what we're looking at, if you have a basic quadratic function, your y equals x squared function looks like this quadratic shape. And you get that shape with the vertex because 0 squared gives you 0. And we're needing to do basically the same thing here, except 0 isn't going to be the value that when squared gives us 0 squared. We need to give x equals 3 to force this to be 0 squared. Now we want this to be 0 squared because 0 squared is the point where we've added essentially nothing to our function. So this function is going to have a -4, which we'll talk about in a sec. And then whatever is in here is going to add to that -4 to make it bigger. And the smallest possible value of this, of course, is 0. So in this case, if x equals 3, then we're going to get 3 minus 3 is 0, and 0 squared is 0. And then the -4 at the end means that the y value of our function is going to be 0 minus 4. So working through, let me show you that. So f of 3 is 3 minus 3 squared minus 4, which is 0 squared minus 4. Now the 0 squared means we're adding nothing to the lowest possible value of our quadratic, which is -4. So this quadratic, instead of our base parabola starting at 0, 0, this quadratic is going to start at 3, -4. So 3 over, 4 down. This is the vertex of f of x. Now just a point doesn't make a very interesting graph. There are other ways you can graph this vertex form, which I'm not going to go into. But one of the simplest ways of getting the critical points only is the same way we've been doing in the last few lessons. The y-intercept we can get from f of 0. So let's do that. F of 0 is 0 minus 3 squared minus 4. The negative doesn't matter. When we square it, it becomes 9 minus 4. So this is going to be 5. So our y-intercept is up here at 5. So I know that I'm going to have a shape like this, and by symmetry I'm going to have a shape like this. And so I'm going to have two x-intercepts. The only question now is what are the x values of those two intercepts? So the way we do that is by finding the zeros of the function. So if you remember, we want the function to equal 0, and then the right-hand side is then our whole function, x minus 3 squared minus 4. So this -4, when it moves to the other side, becomes +4. Remember, the opposite essentially of squaring is plus or minus square rooting. So plus or minus, so root 4 is 2. And this 3 we're going to bring to the other side to be +3. So x is +3 plus or minus 2, which is 3 minus 2 is 1, and 3 plus 2 is 5. So there you have it. You've got your vertex, your two x-intercepts, and your y-intercept. All right, let's try a slightly trickier one that's not going to give us as nice integer values. So let's scroll down here. Okay, so let's make this g of x. So g of x is, let's do -1/2 x plus 6 squared plus 13. So our first step, we're going to need to figure out where our vertex is. So what would we need to put in for x to make this 0 squared? Well, x would need to be -6. So we're going to go across to -6 for our vertex. And then at -6, this is going to be 0 squared. 0 times this a value in front doesn't matter because anything times 0 is 0. So that gives us a y value of 13. And so our vertex is -6, 13. So now let's find our y-intercept. Our y-intercept is when x equals 0. So f of 0 is negative a half of 0 plus 6 squared plus 13. The 0 doesn't matter, so this is just 6 squared. So this is negative a half, and then 6 squared is 36 plus 13. Half of 36 is 18, and the negative sign in front makes this negative 18 plus 13. So negative 18 plus 13 is negative 5. So our y-intercept's all the way down here. Let's see, it's about here, I guess, is negative 5. All right, so we can sketch our parabola right now. Parabola is going to be a nice curve, goes over here, something like that. Now, I obviously need to have an x-intercept somewhere between here and here. It's called the intermediate value theorem. You'll learn about that in first year calculus, but that's basically what it says. Anyway, so we're going to have an x-intercept here and an x-intercept here. How do we find those? Well, by finding the zeros of the function. The zeros of the function, you set 0 equal to your whole function. Negative a half, x plus 6 squared plus 13. I'm going to scroll down a bit. So this positive 13 becomes negative 13 on the other side. Everything else is just chilling where it is. It's cool. Now this 2 underneath is division, so we need to multiply by 2, which makes it 26. This negative sign, when we bring it over, negative and negative makes positive. So that's positive 26, x plus 6 squared. The opposite-ish, right? It's a bit complicated, as you saw my note in the last video, but roughly speaking, the opposite of squaring is plus or minus square rooting. So it goes as plus or minus root 26. So this gives us x equals the positive 6 becomes a negative 6 on the other side, plus or minus root 26. So if we want the exact values, I suppose we could just label them this way. Negative 6 plus root 26 is obviously going to be this one here. Negative 6 plus root 26. And I don't have much room here. I'll try to write it small. Here, there we go. Negative 6 minus root 26. Hopefully you can see that. Which isn't very satisfying. Like when we're graphing things, we kind of want to know what those values are. One way to do it is to say, well, root 25 is about 5. So negative 6 plus a bit more than 5 is going to be, I don't know, negative 1-ish, a bit under negative 1. And negative 6 minus 5-ish is going to be sort of just under negative 11. Turns out if you plug it into a calculator, that's actually what it is. It's actually almost exactly 5.1. It's 5.099. So I guess I'll show this down here. So if we split this into our two different solutions, you get x equals negative 6 minus 5.1, or x equals negative 6 plus 5.1. And so the decimal values are approximately negative 11.1 or negative 0.9. If you want to get really fancy, when you go from an exact value to an approximate value, you can throw a little tilde over your equal sign. That means it's approximately equal to. Anyway, so these values are actually 11.1 and 0.9. I guess I'll label them in red. So this is negative 11.1 approximately, and approximately negative 0.9. And there you have it. That's how you can graph, or sketch anyway, quadratics in Vertex Form, the simple way.